In this example, we have a couple limits to evaluate. We have limit as x goes to 3 pi over 2 of sine squared x plus 6 sine x plus 5 all over sine squared x minus 1. So let's start with that one. The first thing we want to do is just plug in 3 pi over 2 for x and see if we can just evaluate that limit flat out. Note that sine of 3 pi over 2 is -1. And if you're pulling out a calculator to evaluate that, you really need to work on having that memorized, right? That should be something that is on easy recall, right on the tip of your brain, and it's not something you have to think too deeply about. There should be some method of recalling that without having to break out a calculator. So if we were to plug everything in there, we would indeed get 0 over 0, which is horribly undefined here. So let's see if we can make this work using other methods. Note that this thing is of the form u squared plus 6u plus 5 over u squared minus 1. Right? That thing we could easily factor the top and the bottom and hopefully get some cancellation. So we'll do the same thing here with sine. So let's see. So let's do the limit. Still is hanging on. X goes to 3 pi over 2. And we can factor this. Let's see here. I'm thinking sine x plus 1, sine x plus 5. So this is a nice technique when suddenly the limit's not working. Just treat, even though there's signs in there, treat it like polynomials and factor them out. On the bottom we have sine x plus 1 and sine x minus 1. All right. And finally we get our nice cancellation. Now we can evaluate this limit. Right, if we plug in 3 pi over 2, remember sine of that is -1, so we have -1 plus 5 over -1 minus 1. So how about 4 over -2, which indeed is -2. Notice that I didn't spend too much time dwelling on theorems of continuity and whether or not we could bring that limit inside of the rational function to the signs. It's something that just kind of fades to the background as you evaluate these limits, and you don't think too much about it, to be honest. On to part B, we have the limit as x goes to 0 from the right of 1 minus cos squared x over sine x. And note, if we were to just plug in 0 here, we would again get 0 over 0, so that's not going to work. And also, if we factor this top to 1 plus cos x, which would be the first thing that I would try, 1 minus cos x, we still don't get any nice cancellation with the denominator. So that doesn't help us in this case, though that's certainly the go-to first thing to try. Anytime you see cos squared along with 1 or sine squared along with 1, one thing to consider is this trig identity, the old standard sine squared x plus cos squared x equals 1. Okay, and indeed this will do the trick for us here, because note that if we subtract cos squared from both sides, we get sine squared x equals 1 minus cos squared x. So keep this ready to use because it's a very commonly used identity. So if we fix it up now down here in our limit, so we have the limit as x goes to 0 from the right of now this becomes sine squared x over sine x. Well, how nice. Look at that cancellation. This whole thing cancels one of these. So we simply have the limit as x goes to 0 from the right. Actually, from the right doesn't even matter in any of this. I think it's just something to throw us off a little bit. Sine x, and sine of 0 is, of course, 0. Doesn't matter if you approach it from the right or the left. So don't be afraid to use some semi-elegant techniques in evaluating these limits with trigonometry involved. Look to factor, look for identities, look for cancellation. Usually there's a way to move these things around enough to get the limit to evaluate.